Okay, our lesson for today, that is on implicit differentiation. That is lesson 4. So we are going to discuss how we are going to use implicit differentiation and when we are going to use implicit differentiation. So if we are going to look at this one, we have our equation. X to the 6 minus 2x is equal to 3y to the 6 plus y to the 5th minus y squared. We cannot solve for y in terms of x. So if you're going to look at here, we cannot solve for y in terms of x. So cases like this one, we are going to solve this equation. We can find dy dx for this equation by using implicit differentiation. Okay, we have our first example. So given 3x to the 4th y squared minus 7x y cubed equal to 4 minus 8y. So we cannot solve y here in terms of x. So we are going to use implicit differentiation. We are going to find the derivative of x in terms of x, find the derivative of y in terms of x. So we have here, so 3 derivative of x to the 4th y squared minus 7 derivative of x y cubed equal to derivative of 4 derivative of y, that is minus 8 dy dx. So we have here x to the 4th y squared, that is a product. So we are going to use product rule for this one. So we have here 3x to the 4th ddx of y squared plus y squared ddx of x to the 4th minus 7. Okay, this one is a product again. So we have x ddx of y cubed plus y cubed ddx of x. That is equal to derivative of 4, that is 0. Then derivative of y, so you have dy over dx. So next, we have derivative of y squared. That is 2y. Derivative of y without exponent. That's the reason we have 3x to the 4th, 2y, dy dx. Plus, okay, multiply 3 inside. So 3y squared. This time we are going to find the derivative of x to the 4th. So we have 4x cubed derivative of x without exponent. So we have dx over dx. Minus, okay, multiply 7 inside. So minus 7x derivative of y cubed, that is 3y squared, derivative of y without exponent. So dy over dx. So negative here, we have positive. So that's the reason if we are going to multiply negative 7 inside, so you will have minus 7 y cubed, derivative of x, that is 1. So we have here equal to negative 8 dy dx. So we have this one. 3x to the 4th, 2y dy dx plus 3y squared, 4x cubed dx over dx. We can cancel this one. Minus 7x, 3y squared dy dx minus 7y cubed, that is equal to negative 8 dy dx. So if you are going to look at here, we are going to combine all dy dx. So we have dy dx here, we have dy dx, we have dy dx. Since we're solving for dy dx, so combine all dy dx. So dy dx, we have 3x to the 4th, 2y. That's the reason we have 6x to the fourth y. And then here, dy dx, this is 7 times 3, that is negative 21 here. So negative 21 xy squared. And then this one, that is, we are going to transpose to the other side. This is negative. If we are going to transpose to the other side, that becomes positive. So that's the reason we have here plus 8. Then this one, if we are going to transpose to the other side, 7y cubed. Transpose, that is negative, that becomes positive. That's the reason we have 7y cubed. And then we have 3y squared, 4x cubed. 3 times 4, that is 12. So that's the reason transpose to the other side, that becomes negative. So negative 12, 3 times 4, 12, x cubed, y squared. So, therefore, dy dx, that equals to 7y cubed minus 12x cubed y squared over, okay, over 6x to the fourth y minus 21xy squared plus 8. So, that is now the final answer. Okay, next example, example number 2, that is find dy dx given x cosine y plus y cosine x equal to 1. So, for this given, we cannot solve y in terms of x. That's the reason we are going to use implicit differentiation. So, to solve, so d dx of x cosine y plus d dx of y cosine x, that is equal to d dx of x. So, x cosine y, that is, we can find the derivative of x. We can find the derivative of y. So, we are going to use product. So, we have here x d dx of cosine y plus cosine y d dx of x. So, plus, okay, plus derivative of y cosine x. So, we can find the derivative of y. We can find the derivative of cosine x. So, we are going to use product. So, formula of a product. So, y, derivative of cosine x, plus cosine x, derivative of y. That is equal to 0. So, we have here derivative of cosine y, that is equivalent to negative sine y. So, that's the reason we have here negative x sine y, derivative of y, okay, derivative of y over dx, plus cosine y, derivative of x, that is over x, derivative of x over dx, that is cancelled out. That's the reason we have 1 here. Next, derivative of cosine x. Derivative of cosine x, that is negative sine x. So, that's the reason we have here y, negative sine x, derivative of x over dx. Plus, derivative of cosine, derivative of dy. So, therefore, plus cosine x dx, dy over dx. So, we have now that form. So, negative x sine y dy dx plus cosine y, because we have negative inside here, so minus y sine x plus cosine x dy dx. Okay. Wherein your dx over dx here, that is cancelled out. So, therefore, we are going to combine all dy dx. So, if we are going to look at here, dy over dx, so we start with positive. So, cosine x minus x sine y equal to, okay, transpose this to the other side, that becomes positive. So y sine x. Transpose this to the other side, that would become negative. So we have negative cosine y. So therefore, dy over dx, that is equal to y sine x minus cosine y over cosine x minus x sine y. So this is now our final answer. Okay, example number 3, we have x plus y squared minus x minus y squared, that is equal to x to the fourth plus y to the fourth. So find dy dx. So if you are going to look at the equation, we cannot find y for that in terms of x. So we are going to use implicit differentiation. So let's try to solve. So ddx of x plus y squared minus ddx of x minus y squared is equal to derivative of x to the fourth plus derivative of y to the fourth. So we have an exponent here. We start with an exponent. So exponent is 2. So 2x plus y, 2 minus 1, that's the reason you will have 1. You don't need to write the 1 exponent here. So I just write here for illustration. Then derivative without exponent. So you will have x plus y. Then minus 2. Okay, you have an exponent here. So minus 2, x minus y, 2 minus 1, that's the reason we have 1 here. Derivative without exponent, so x minus y, that is equal to derivative of x to the fourth, that is 4x cubed, derivative of x without exponent, so that's the reason you will have dx over dx, plus derivative of y to the fourth, that is equal to 4y cubed, derivative of y without exponent over dx. So we have 2x plus y, derivative of x, that is 1. So that's the reason you will have 1 here. Derivative of y over dx, dy dx, minus 2, x minus y, then we have derivative of x, that is 1. Derivative of y over dx, that is equal to 4x cubed, because you can cancel dx over dx, plus 4y cubed dy over dx. So we are going to multiply 2x plus y inside 1 plus dy dx. So what will happen? 2x plus y times 1, that's the reason we have 2x plus y. Then multiply again, multiply inside 2x plus y times dy dx. So that's the reason we have 2x plus 2y times dy dx. So multiply this inside. Okay. So do it here. So that's the reason we have here. So we have here 2x plus y times 1. So that's the reason you will have 2x plus y plus 2x plus y times dy dx. So you can multiply 2, distribute 2 inside x plus y. So that's the reason you will have 2x plus 2y times dy dx. Then here, this one, distribute to 1 minus dy. So that's the reason we will have negative 2 times x minus 1 times 1, negative 2 times x minus y times 1. That's the reason we have negative 2 x minus y. negative 2 times x minus y times negative dy. So that is negative, negative. So that's the reason we have positive. So you will have plus, okay, negative 2x. So you will have plus 2 times x, 2 times negative y. So that's the reason you will have 2x minus 2y times dy dx. That is equal to 4x cubed plus 4y cubed dy dx. So if you are going to look at here, we are solving for dy dx. So we are going to combine all dy dx. So if you are going to combine dy dx, so dy dx, okay, that one. So dy dx, 2x plus y, okay, 2x plus y, 2x minus 2y, 2x minus 2y. This is 4y cubed. That is positive. If we are going to transpose to the other side, this would become negative because this is your equal sign. Transpose to the other side, so that becomes negative. So at the right side, we have 4x cubed. So 4x cubed. This one is negative. Transpose to the other side, that becomes positive. So positive 2x minus y. This one is positive. Transpose to the other side, that becomes negative. So that's the reason we have negative 2x plus y. Okay. So what happened here is that 2x plus 2x, that is 4x. 2y minus 2y, that is 0. So cancelled out. So what is left is negative 4y cubed. So you will have 4x minus 4y cubed. Here we have 4x cubed. 2x minus 2x, if you are going to distribute 2 inside, that becomes, so what we have here is 2x minus 2y minus 2x negative 2y. So that's the reason we have 2x minus 2x, that is 0. So negative 2y minus 2y negative 4y. So that's the reason we have here 4x minus 4y cubed, that is equal to 4x cubed minus 4y cubed. So the final answer, here, we have dy over dx, that is equal to 4x cubed minus y, because 4 is common. So do with the other one. 4 is common. So 4x minus y cubed. You can cancel 4. That's the reason the final answer is x cubed minus y over x minus y cubed. That is now the final answer. So we have here practice problems. So you try to solve this one. Solutions for this one, you are going to pass at our Google Classroom. Okay? Only solve this one, and your answers, please pass at our Google Classroom. Okay? Thank you. So next time we will be discussing on logarithmic and trigonometric functions. Thank you.